Hi, I am Francesco Martella, a PhD student at the University of Messina, and I would like to tell you about our work, Virtual Device Model Extending NGSI-LD for FaaS at the Edge. Before presenting our work, I want to thank my advisor, Professor Massimo Villari, and the colleagues who contributed to this work. In this presentation, we start with a brief introduction and present a use case. After, we discuss our work and we talk about the conclusion and future works at the end. Nowadays, smart environments are challenging contexts to offer a new generation of services on the basis of huge amounts of gathered data and pervasive processing. In particular, distributed edge computing solutions move data processing closer to end users, and for this, a challenge now is to move services from cloud to edge. The users require more proximity services, and these require an abstract representation of heterogeneous resources. In this work, we analyze a use case on video surveillance in a smart city environment. In particular, we analyzed the city of Messina, located in Sicily, Italy. The municipality of Messina is a pilot with Helsinki, Bilbao and Amsterdam of the Horizon 2020 project Urbanite. And in this context, we want to apply the concept developed in this work. The motivation behind this work relates to our interest in the edge computing. We believe that smart environments today need real-time services that respond quickly and fast, even in the absence of cloud connection. To abstract the computational resources, it is necessary to decouple the processing activity from the physical device. This will allow high flexibility of configuration of the devices as well as the large-scale repeatability of the system. Our goals in this work are to define an appropriate model of virtual device and start from this model define a data model for the characterization of virtual devices that can be heterogeneous. In our vision, a virtual device is an abstraction of a physical device that emphasizes specific features or functionalities of the device itself. This concept is outlined in the figure at the right. We can see the physical device and the virtual device. In particular, the edge unit is a physical device at the edge, and it can be connected to a sensor or more sensors for gathering and after processing data from the environment, for example, measurement of temperature at specific time intervals. With this approach, data collection and processing tasks are strictly related to the type of binding between the edging unit and sensor. A virtual device maps several behaviors of the virtual edge unit with the ones of the virtual sensor. As shown in the lowest part of the figure, the virtual device allows to decouple different possible activities executed into the edge unit by using data coming from the sensor, such as average temperature or max temperature, thus increasing the flexibility in data processing. In particular, through a virtual extender, this is a component, it is possible to connect n functions, represented by colored dots in figure, in the virtual edge unit with the same amount of functions in the virtual sensor. In this way, it is like n different physical devices are available. The virtual extender, together with the edge unit, identifies the virtual edge unit, which communicates, how we can see with the colored arrow, with the virtual sensor by means of the virtual function component. The virtual function, together with the physical sensor, define the concept of virtual sensor. The virtual edge unit and the virtual sensor compose the virtual device. To use this concept of the virtual device in a data model, we need to know the NGSI-LD standard. NGSI-LD is an open standard for managing context information and improve the management of linked data. In particular, NGSI-LD was released by ETSI specification to change FaaS NGSI version 2 standard. The key concepts of NGSI-LD are entities, properties, and relationships. Entities are objects with specific properties and can be in relationship with other entities. Properties are a combination of attributes in the form key value, like a JSON. Relationships allow to establish logic connection instances through linked data using a property that points to another external resource. An example is the use of uniform resource identifier. To include the concept of virtual device within the NGSI-LD data model, it is possible to create an extension of the standard that abstracts the concept of physical device. The extension is accomplished by adding information to the payload of the model, thus to have a more flexible data model. An example of the extension of NGSI-LD is shown in the case of an edge device with the ability to support virtual device. Considering the capabilities reached by current edge computing devices, it is possible to imagine several independent processes running at the edge that elaborate data in different ways. This entails a considerable economic advantage in the deployment of edge solutions on a large scale. The physical device can be, for example, a microcontroller with a temperature sensor attached. The virtual device VD1 can provide data in real time, the virtual device VD2 the daily average temperature, the virtual device VD3 the weekly average temperature, and the virtual device VD4 the maximum weekly temperature value. The limit of the number of virtual devices depends only by the processing limits of the microcontroller. Application asking for service will see a dedicated services, but in reality they will access information processed at the edge, and the edge is only one. The request and the access to the services from an application need to be defined and managed through a data model. This is possible even for service on demand. In the data model, each physical device and each virtual device had an ID. The ID is unique. The virtual device is linked to a specific physical device by the ref device model property. At the controller property contains the actual function of the virtual device. It can be changed. The use case we analyze in this paper concerns a video surveillance system in a smart city. Edge devices are designed to offer miscellaneous microservices. The only limit for request specification is the physical one. To simplify the concept of service officer, we imagine an EPCAM. This is true in our use case. The EPCAM can acquire 25 frames per second. This is the physical limit of the device for this device. The virtual device could offer to a specific actor 10 frames per second, but it will never can offer 30 frames per second. For this, in our vision, a virtual device is an extension of an NGSI-LD physical device definition type in which we introduce the specific configuration. The specific configuration is 25, 10 or 5 frames per second. Another Another specification, another configuration is the solid angle. The solid angle is an extension in three-dimensional space of the plane angle. The concept of solid angle in a video surveillance application in a smart city is important, in our opinion, because it allows the identification of targets. This is useful in the transport's recognition type for the vehicles, for example. In the vehicles recognition application, for example, for recognized vehicle, but this can be useful for any type of target. For example, a person in emergency situation, such as a terrorist attack. The system that adapts to the situation can therefore also allow you to follow the target in the city. And if you think a vehicle or a person in the same, and we can focus on the target and follow in the city. The use case present in the data model with an array of values for the virtual device category. We have the category, and the category represent in the value key represent our specification, our services. The virtual device will always associated with the physical device by means of the ref device property. But we need to see the development phase. In this case, through the deployment info property, it will be possible to configure FaaS on the device for a new deployment even in real time with the desired service category. In this case, we insert the configuration file of FaaS in the NGSI-LD file configuration, and the device is able to read the information and deploy a new service. The proposed work represents, in our opinion, a new approach to edge computing. It is possible to deploy virtual devices for specific functions with data models useful in the smart city environment. The next steps of this work will be deploying a video surveillance services in Messina with the characteristics described, and we want to integrate the proposed work into the FireWare ecosystem and for increase the FireWare ecosystem capacity to manage device and data, and we want to apply this concept in the Urbanite project for better results at the end of the project. Thank you for the attention, and if you want, this is my contact, keep in touch.